Hey, what is up, everybody? It's Mr. Murray here, Mr. Murray's Mathland. Today we are taking a look at condensing logarithms, and to do so really requires using three properties. Three properties we're going to look at first before we do a few examples. So the first property is adding logs. How do you add two logs together? Well, first of all, they need to have the same base, whatever that may be. And if you're adding two logs, you can condense it to a single log with the same base. That base doesn't change, of these two arguments, a and c, multiplied together. So a times c. And that might make sense to you, actually, if you think about logs just represent exponents, right? And you're adding two exponents. And when do you add exponents? When you're multiplying bases. So, there's a correlation there. So it's not just coming out of nowhere. And subtracting is, of course, very similar, except the opposite of addition. So we can condense two logs together, log base b of, if we are subtracting, that would be a divided by c. And that also might make sense too, because if you are talking about a negative log, that's a negative exponent, and negative exponents, cause you to move that to the denominator. You're dividing by that quantity, or it makes reciprocals. Okay, and the last property here before we get into this is called the power property, and that's if you have a coefficient in front of a log. You can get rid of that by making it an exponent, by raising that argument, whatever it is, a in this case, to that power of c. So, okay, so those are the three properties we're going to need to do these problems, because they all say the same thing: condense each expression to a single logarithm. Okay, so we'll do number one here. And first things first, we're trying to add these two logs. They're both log base 5, and I'm trying to add them together. So I'm going to use my addition property. But first, you may notice that this one has a 4 out in front. So if I have any coefficients other than 1 or negative 1 in front of these logs, I'm going to first take that, use my power property, and raise my argument to the 4th power. Now just be careful here. I'm going to try to not do too much, since I'm trying to show this step by step, that you have to raise not just the x squared, you have to raise the entire argument, 3x squared, to the 4th power. So 3 to the 4th power is 81, and x squared to the 4th power is x to the 8th, right? Power to a power, you multiply those exponents. Now the other log already has an exponent, or excuse me, a coefficient of 1, so we'll just leave that as is. And now we can add these two logs together by using our addition property. I can condense them to log base 5 of, and now I'm going to multiply these two arguments. 81 times 10 is 810. X to the 8th times x to the 4th is x to the 12th. When we multiply, we add those exponents, right? Okay, and there we go. There is our answer, log base 5 of 810 x to the 12th. If you feel like adding parentheses around it, around the argument, feel free, but not necessary in this case. Okay, so number 2, we are subtracting two logs with base 5, but I do want to look for coefficients first. The first log has a coefficient of 1, so we're good. The second log has a coefficient of negative 3. So I'm going to leave the negative there, and I'm going to take this 3 and use my power property and raise that argument to the 3rd power. So I'm going to take my time and rewrite this whole expression, but just with that simplified. So again, you want to raise that whole argument to the 3rd power. 2 to the 3rd is 8, and x cubed to the 3rd is x to the 9th. Okay, now we are subtracting two logs with the same base. I can condense them to log base 5 of, and the positive argument, goes on top. The negative log, you put that argument on the bottom. You're dividing by 8x to the 9th. That's all on the inside of the log. And if you can divide them, or if you can simplify that fraction in any way, you should always do so, right? So this one you may already be noticing. There's some definite simplification that can be done. 12 divided by 8 reduces to 3 halves, and x to the 5th over x to the 9th. X to the 5th will cancel and leave you with x to the 4th in the bottom. And there we go, 3 over 2x to the 4th on the inside of that log base 5. Okay, so there's an example of addition and subtraction. I've got a couple others though, a couple more, a little more complex ones, but those are two pretty good examples, and we used all three properties there. So let's just take a look at something like this. There are 3 logs here, and so one thing you might like to do as your first step is to look at all those coefficients. Anything that's not 1 or negative 1, deal with it by using the power property, right? So I'm going to take this 4, and I'm going to raise that z to the 4th power. I'm going to take this 2, and I'm going to raise that z to the 4th, to the 2nd. I'm going to take this 1/2, and I'm going to raise this 9z to the 10th to the 1/2 power. Then I'm going to take my time. So I'll have log base 7 of z to the 4th minus log base 7 of z to the 4th to the 2nd is z to the 8th, plus log base 7 of, now when you raise something to the 1/2 power, remember you're really taking the square root of it. So the square root of 9 is 3, and z to the 10th to the 1/2 is z to the 5th, or the square root of z to the 10th is z to the 5th, however you like to think about it. But just watch out for that 9 raised to the 1/2. Sometimes people get a little sloppy and say 4.5 or something like that, but that's taking the square root of it. Okay, so now we've got 3 logs here, and when you're comfortable with these, you could do the next part all in one step and get right to the final answer. But suppose, this video you're still a little shaky with these properties. I'm just going to do them 2 at a time. The first 2 I see, I'm going to condense these. So I see log base 7 of z to the 4th minus log base 7 of z to the 8th. Well, I'm going to divide them. So that's going to be z to the 4th divided by z to the 8th. Right? That's how you subtract 2 logs. And then you also have this plus log base 7 of 3z to the 5th here. So you might be seeing all kinds of things you can do. I could reduce this, but I also am now going to add this log to that one. So it's kind of up to you. I'm going to go log base 7 of, and if I'm adding the 2 logs, then that means I'm going to multiply the argument. So when I'm multiplying this fraction by this, remember you're really just multiplying that numerator by that. So that's going to make 3z to the 9th in the numerator over z to the 8th. And now if you haven't reduced, you definitely want to. Z to the 9th divided by z to the 8th is just z. So log base 7 of 3z. And there you go. There's the final answer. So if you felt, this one I took 2 steps to do this. I condensed these, and then I condensed these 2. But in the future, you might really go right to this step by just saying, hey, anything, going from here to there, anything that's a minus means I'm dividing by that argument. Anything that's a positive means I'm multiplying. So you could really just go right to that by putting these in the numerator and multiplying them, of course, 3z to the 9th, and then putting z to the 8th in the denominator, and then reducing, if you didn't want to take your time and do that. But totally up to you, as long as you're comfortable doing these without making careless mistakes. And just to illustrate this, what about when you've got a couple subtraction signs? Believe it or not, this is commonly mishandled by students. So just going to take my time. In fact, I didn't even put any coefficients here, so I'm not doing any power properties here. just ln of a minus ln of b. Well, I'll condense those and I'll get ln of a over b. Then I also have minus ln of c. So if I'm going to condense these two, then I'm doing a over b divided by c. And when you divide by c, that's really multiplying by 1 over c, right? So all that's really going to do is put c right in the denominator with b, and multiply them together. So there's my final answer. That can't reduce. But I just really wanted to show you this, that notice how if you're subtracting, any logs like this, I really just end up putting those arguments in the denominator and multiplying them together. And anything that's a positive log, I put it on top. So ln of a over bc. And last problem here where we'll put it all together. Got 3 logs here, got all kinds of powers and coefficients, so let's take care of those first. So 1/3 becomes a power, so I'm going to raise the argument to the 1/3 power. This coefficient of 2, I'm going to raise that argument to the 2nd power. The last log has a coefficient of -1, so I'll leave that as is. And now here we go. 8 to the 1/3, that's like taking the cube root of 8, right? And the cube root of 8 is 2, and x to the 12th to the 1/3 is x to the 4th. Minus ln of, and now I'm squaring that whole argument there, 5x y to the 3rd squared will give you 25 x squared y to the 6th. Minus ln of 3x to the 4th y squared. Okay, so here's where I'm going to do this all in one step, at least my condensing it to a single log, rather than take a step and condense these two, then condense that new one with the third one. I think we should be able to handle this, that they're all ln's, natural logs, so I can put them together in one natural log. And here's the deal. Anything that's a positive coefficient goes in the numerator. So 2x to the 4th goes up top. Anything that is a negative coefficient means I'm dividing by that, so I would put that in the bottom, right? I'm dividing by that. And I have another one where I'm subtracting, so I'm dividing by this also. And so dividing by that means putting that in the denominator and multiplying it by that other quantity there in the denominator. And now just simplify this. So a lot of stuff going on here to simplify. Just take your time. So we'll leave that alone, 2x to the 4th. When I do multiply those in the denominator, 25 times 3 is 75. X squared times x to the 4th is x to the 6th. Y to the 6th times y squared is y to the 8th. And now that fraction can certainly be reduced. 2 75ths stays just as 2 75ths. But x to the 4th divided by x to the 6th leaves x squared in the denominator and y to the 8th in the denominator. So there we go. Okay, so hopefully from this variety of examples and subtle nuances, you got the real hang of how to do this. And if you've got any other questions, feel free to ask. And as always, keep working hard.